Today, in this video, we are going to implement the gradient boosting algorithm. First of all, what is gradient boosting algorithm? It is a very powerful boosting algorithm that combines server weak learners to combine a strong learner model, in which each model is trained to minimize the loss function, such as mean squared error or cross entropy of the previous model using the gradient descent. In each iteration, the algorithm computes the gradient of the loss function with respect to the prediction of the current assembles and then trains a, trains a new weak model to minimize this gradient. So in this algorithm implementation, so we are using the Boston housing dataset. You can download from the Kaggle. So currently I'm using this boston.csv file here. So I have imported that CSV file. So these are the necessary libraries, that is NumPy and Pandas you have to import. Then here I am doing the data preparation. I am reading my CSV file of the housing dataset. Then this is how the dataset looks. So this one is the you can say the target column. So here my target column is like the median value of the owner occupied homes in $1,000. So it is basically the you can say uh, the amount in $1,000, the average value. So these are the my independent columns. So here you can see per capita crime rate by the town and the proportion of residential land zone for lots over 5,000 square feet and the proportion of non-retail business acres per town. So you can read all the you can say the column description. So next what I am doing is that I am taking out my dependent and independent columns. So these are my you can say independent columns. Here is in why I am taking my dependent column. Then I am dividing the my data set into the training set and the test set. So I am taking the training size as 75% and the test size is 25%. Then I am giving this data to my gradient boosting regressor. So here I am making the object of the gradient boosting regressor, that is the gradient regressor. Here I am using the various parameters like the maximum depth to here to the number of estimators for the weak learners. I am using 5 and the learning rate equal to 1. You can fine tune these various parameters of the algorithm. Then I am passing my training set to the gradient regressor object by using the fit method. Then I'm making a prediction on the test set. So here I'm using the accuracy as to score. So you can check the model's performance is here 80%. So and there is one option is also there, like we can also check the importance of the features, like which column contribute more to the model. So you can use model dot feature underscore importances underscore. So here you can see it's IND array. So here you can see the like the 66% and all the contributions of the all the columns to the model. So here I have plotted the graph. So this is nothing but I am plotting the graphical representation. Like so, you can see LS that this column contributes more, and it takes DIS, RM, and NOx, and CRIM. So you can check the description like CRIM. So what is it is? So like the this is contributing more lower status of the population, so it is true, and the per capita crime rates by the town here. So these are the columns which are contributing more. You can say relevant. Then So this one is the here what I am doing is I am fine tuning the models of the our this algorithm. So I am using here grid search CV, that is cross validation. So what it's doing is that, so here like I am taking different values of the two parameters, that is the learning rates and the number of estimators, the number of estimators. So here what I am doing is that it will try with different combinations of each parameters and it will choose the best combination for the model. Okay, like what is doing, suppose I am taking learning rate 0.50, so it will go with the estimator 50 one by one. Then I am again taking 0.50 and 0.15 as the learning rate, then it will take estimator as 100. Then again 0.15 as a learning rate, then again 150 as a estimator. So it will make different combinations and it will fit on the you can say pass these parameters to the model and we will get the best parameters which are having the highest accuracy. So here the best parameters are having the learning rate, you can say zero point 0.1, and the number of estimators I am getting 150, and the accuracy is increased from 80% to 87%. So in this way, you can implement the gradient boosting algorithms. Here, I have done nothing much fancy like the feature engineering part, and you can say. So here, my motive is just to run the gradient boosting regressor. So you can do various other, you can say, uh, other methods, or you can say transformations and feature engineering, and to increase the performance of the model.